2.1 Pre-Calculus Day 1, video number 3. We focused on the quadratic equations, graphing them with transformations and in vertex form. Our last one is factored form, where you have two parentheses going on. Step 1 is to convert this equation into standard form, so multiplying it out, FOILing it out. Then you're going to do the same steps as we did on the last slide. You would do 1 through 4. You would find the x of symmetry, the vertex, the y-intercept, and if it opens up or down. We're just actually adding one extra step to this. We want to find the x-intercepts. To find the x-intercepts, we factor it, and in this case they'll already be factored, and you use the zero product property. You set those factors equal to 0 and solve for x. Those are going to be your x-intercepts. So on the next slide is an example that will go through these steps. So I'll give you a little bit of time to write that up. All right, here's our example. H of x equals negative, and then in parentheses is x minus 2 and x minus 4. This is in factored form, and we want to be able to graph it. So the first thing we want is we want to convert it to standard form by FOILing it out, so we can identify what is the A, the B, and the C. So to FOIL this out, I'm going to multiply just the parentheses together for right now and ignore the negative. So it's x squared minus 4x minus 2x and then plus 8. I'm going to combine like terms in the parentheses. And then I'm going to distribute the negative through. So it's negative x squared, positive 6x, negative 8. I've converted this equation now to standard form so that I can identify the A, B, and C. So the A value is negative 1, the B is 6, and the C is negative 8. All right, we're set to find the first thing, the axis of symmetry. Do you remember the formula for the axis of symmetry? That formula is x equals negative b over 2a. So let's go ahead and find that now. So x equals negative, and then our b is 6 over 2, and our a is negative 1. So we get negative 6 over negative 2, which is 3. So the equation for the axis of symmetry is x equals 3. So over on my graph, I would go over 3 units and draw a vertical line. Now the next thing is to find the vertex point. Remember the vertex, the x value of the vertex is the x value for the axis of symmetry. To find the y value, we have to substitute 3 into the function. If we want to use the original blue function or now the converted red function to standard form, it doesn't matter. I'm just going to stick with the original blue function. So I'm going to drop the h of x and just change it to the letter y, and then negative x minus 2, x minus 4. Now I'm going to substitute 3 into each of those x places. So 3 minus 2, 3 minus 4. Do my orders of operations, my parentheses first, and then multiply. Negative 1 times negative 1 is 1. So my vertex then is 3, 1. So on my graph, I would go over 3, up 1. It's like my smart board needs to be recalibrated. All right. I can next find the y-intercept. The y-intercept is the c of the equation in standard form. So if I go up to that red equation, the c is negative 8. So my y-intercept then is 0, negative 8. I also noticed from my original equation or my standard form equation that my a is negative. So my graph must open down. I'm going to graph my y-intercept over 0, down 8. Two things left. Let's find the intercepts for the x-axes now. To find the x-intercepts, we're going to set each factored part, so those parentheses, equal to 0 and solve for x. So one of the factors is x minus 2. The other factor is x minus 4. So when we solve those for x, we add 2, and we get x equals 2. So the x-intercept there is over 2 up 0. On this side, we would add 4 and 4, so x equals 4. So the ordered pair is 4, 0. This is called a zero product property. So we can graph those two intercepts, 2, 0 and 4, 0. Now I can graph it. Here's my vertex going through the x-intercept, going through the y-intercept, and then down here, this should be down 8 also. And there is my parabola, opening down. There is my homework for 2.1, day 1 on page 116, 1 through 8, 13 through 25.